I'm Ian Clark, and this is my Interactive Advanced Concept Presentation 8, the instant ice experiment covering surface tension. And so I've had 2 purified bottles of water in my freezer here. They've been in almost exactly 2 hours and 45 minutes. So we're going to pull them out and try the few of the experiments to see if we can create some liquid ice. First one, I'm just going to pull it out and hit the bottle on the table and see if, when that happens, if it'll create instant ice. The second one, I'm going to attempt to pour it into the glass and see if we can create some. And then the last one, I'm going to try to put some water into the glass and add an ice cube and see if that creates some instant ice. So a little bit about the science behind it. As we know, water freezes at 32 degrees Fahrenheit, and when that happens, the molecules come together tightly, and they form a crystalline solid structure from a liquid, and then that's the phase change. So what happens in this, hopefully we'll see it, is nucleation, and the phase transition. It's the forming of crystals when a liquid goes to a solid. And this usually happens very abruptly, but normally we don't see it because as latent heat is released, it goes over a time period. So we don't see this happen as quickly as we're hoping to see it in this experiment. And this is caused because there's a free energy barrier, which is caused by the surface tension of the water. The surface tension, the free energy barrier, causes it to remain a liquid even though it's below freezing, so it'd be super cooled. And it doesn't freeze, or we don't see this crystalline structure become created until we interrupt it somehow and break that free energy barrier, either by shaking the water and making a small bubble that breaks the free energy barrier, or we pour it out, or we introduce some kind of impurity into it. And since this water is pure, until we interrupt it in some way to break that free energy barrier, to break the surface tension, we shouldn't form any ice, even though the temperature is below 32. So I'm going to pull them out. I'm hoping they're not frozen solid. For this experiment, we're going to give it a shot. Well, this one's kind of slushy, as you can see. They've all started freezing. Let's try this last one. They've all started freezing. This one is the least frozen. I don't know if possibly this experiment it's pretty cold in the house right now, so I don't know if this is what caused it, or if maybe this water just wasn't that pure because it's mineral enhanced, so possibly that's what caused it. We'll still see if we can pour some of this into the glass and if it'll instantly the top's frozen solid. That might have been our issue. Well, can't get into any of these because the lid's frozen solid, unfortunately. Well, unfortunately, this experiment doesn't look like it functioned for me, but if it would have worked properly, we would have been able to hit the ice or rub it down, and we would have seen ice form instantly, as we would have broke that free energy barrier, broke the surface tension. And when that happens, the crystalline nucleation happens when that crystalline structure is created almost instantly, and we have a little bit of a slushy mixture from this as the water transitions, that does the first order phase transition from a liquid to a solid. Unfortunately, these are all froze most of the way through. I tried to time it according to the explanation, but thought maybe we would get a little bit out of there, but unfortunately the experiment did not work for me. But hopefully the science behind it is explained, and that's my Interactive Advanced Concept Presentation number 8.